Ecopetrol is now building the second stage of the Cupiagua LPG and NGL plant of the Colombian Plains, which is a complex that is located in the department of Casanare, in a rural area of the municipality of Aguazul. The Hub Llanos management of the Vice Presidency of Engineering and Projects is building a condensed stabilization unit, a facility that will allow 22.7 million barrels of oil, equivalent to already incorporated reserves, to be processed for NGL, LPG, and C5 sales. The company to reliably maintain its volume of sales of gas in 210 million cubic feet daily. The company to protect the gas reserves incorporated in the first stage of the gas plant. The CPF occupies an area of approximately 70 hectares, and the new condensing plant will be a part of this area. This new construction implied an expansion of the access areas and meant that 2 new internal roads had to be built for the 35 tank truck to pass through daily. 1 access road to the north end of the site and another exit road to the south end, as well as a processing area with 2 separating towers or columns, 2 storage areas, and 1 area destined for filling up tank trucks. It was also necessary for the company to expand 800 meters of access roadways to the CPF and to build a new bridge over the Cupiagua River in order to meet the transit requirements for the 35 tank trucks that are expected to access the plant daily. Internal roads present 1 exclusive access and exit lanes. The north section's 1,500 meters of roadway will take the tank trucks to the filling area so that products may be loaded onto them there. The south section's 1,300 meters will allow the loaded trucks to be safely dispatched to the whole of Colombia from there. The new stabilization plant is fed by an initial average flow of 16,500 barrels daily that leave through the condensing unit of the Joule-Thompson unit in the gas plant. These liquids are currently being recirculated in the process while waiting for the new plant to begin operations. The objective of the hot oil system is to provide the thermic energy that is needed in the separating columns, a process that is carried out by combustion in 4 burners of approximately 1 million cubic feet of fuel gas daily that heats up the oil to 550 degrees Fahrenheit. This energy is transferred by convection and radiation. The dethanizer unit is a 34-meter-high distilling tower with 34 internal plates or trays that permit the separation of condensed flows by coming into contact with each plate between the descending flow and ascending vapor. This is how the products are rectified and how liquid LPG, C5, and NGL are obtained at the bottom. The dethanized flow is sent to the debutanizer column, and light products made up of methane and ethane are obtained at the top. These gases are then sent to the compression unit. The columns need the heat that comes from the reheater. A thermic exchange then occurs that transfers the heat of the hot oil to the fluids in the column. In this manner, thermal heat gain makes it possible for the condensed products to be separated. Similar to what occurs in the dethanizer, the debutanizer column is a 33-meter-high distilling tower with 41 internal plates or trays that permit the dethanized condensed products to be separated according to methods of operation. Finally, the products are rectified in every plate between the descending flow and ascending vapor. At the top, the gas obtained is sent to the compression unit and the condensed LGP to the 3 storage spheres. NGL is obtained at the bottom and is then sent to the storage tanks. A flow of C5 is obtained in the middle plates, in the form of heavy GLP product and light NGL, which is then sent to the C5 sphere. Similar to what occurs in the previous stage, the reheater of the debutanizer tower uses the hot oil that comes from the oven to transfer heat to the liquid that flows to the bottom of the tower and generates the vapor that is needed from the separation process. The gas that comes from the top of the towers is taken through suction of the reciprocating compressors of the compression unit, a system that compresses gas from 320 psia pounds up to 625 psia pounds, and which is then sent to the CPF's medium pressure reinjection system. In order to maintain the LGP in a liquid state, it is essential that it be stored in spherical tanks. In the case of the Cupiagua condensed products plant, 3 spheres are needed with a nominal capacity of 7,900 barrels. According to methods of operation, 8,600 barrels of LGP are received daily from the debutanizer column at 170 psia pounds of pressure. This product is then pumped to the filling station for transport purposes. C5 also requires special pressure conditions for storage purposes. In order for this to be done, there is a sphere whose nominal capacity is 2,840 barrels, which may receive 1,200 barrels of liquid C5 from the debutinizer column at a pressure of 24 psia pounds. The product is sent to the dispatch area while it is being received. The NGL storage area has 2 tanks. The largest one has a capacity of 5,300 barrels a day, and the smallest one, 3,000 barrels. NGL is stored in atmospheric tanks since the vapor pressure is inferior to the atmospheric pressure of the site at the temperature when it is stored. The 3 products are pumped from the storage area to the filling station in order to be transferred to tank trucks that will take them to the final client. LGP as a fuel and an alternative to natural gas, C5 and NGL as dilutants for heavy crude oil to be used when it is being transported. When the condensed plant is put into operations, this will help to reduce imports of these products and to provide the products for a growing demand of the national market.